So I want to show us how we can use the base 10 blocks to show multiplication of decimals through this. It'll be through the area model. But first I want us to remind us of, we want to call each of these pieces not necessarily a 100s flat, a 10s rod, or a unit cube, but just, or, unit is fine. Oh, I wonder why that's writing so strange. But just call it the rod, the flat, the flat, and the unit. Why we want to do that is because we're going to define a whole, not necessarily by this guy, right? We want this multiplicative relationship, right? The rod is 10 times bigger. The flat is 10 times bigger than the rod, or 100. I don't know what's going on with my pen here. 100 times bigger than my unit. So that's a really important, this multiplicative relationship is part of our place value, base 10 structure. So that's really important to note. So I'm going to clear all these drawings. And so what I want you to see, or what I want to do is, now, what if we called this guy, and maybe 1, this is then a 10th, and then this one is going to be 100th. And so I'm going to delete him. And so let's see if we did 2 3/10 times 1 4/10. Let's multiply those two numbers, and I'll show you how we can represent this. So we want to think about, and I'll just delete all of these, right? If this is 1, and we're looking at our first factor up at 2 3/10, right? So if this is 1, then this is 2. And 3/10 would be 1, 2, 3. And likewise, you're going to see, I'm going to set up kind of this idea of an area model like we've been working with. And right, we've been calling it kind of like the box method, right? So this is the same as 2 3/10. And then over here is going to be 1 and 1. Oopsie, wrong one. 2, 3, 4. Why this is so important is because now we're going to look at the area, or the space in between, right? All of this space here. And so we see this kind of in a way of like a grid or an open array, and you can multiply it, kind of exactly equivalent to this idea of partial products. But I want you to see how we can think about it with the numbers, with the blocks. So this number, right, this guy right here is a whole, right? This is 1. This is a 10th. This is a 10th. This is a 10th. Likewise, this is 1, 1/10, 1/10, 1/10, 1/10. So you can write it, in your numerals as numbers, but let's look at about as area. Think about what is, right, 1 times 1. 1, right? And we can see that how a flat times a flat is going to give us another flat. What about 1 times 1? Right? So the same idea of this partial products, like, right, the dimensions, the left times the right, or the left side times the top. And the same reasoning. Now, what's 1/10 times 1? 1/10, right? Anything times 1 is itself is the multiplicative identity. And we could do that, right? Another 1/10 times 1, another 1/10 times 1. Likewise, here's another one, and here's times 1/10. 1, 2, 3, 4, right? 4/10 times 1 is 4/10. And we're going to do that again, right? 4/10 times 1. I just did that for the sake of not having to drag them all over. But now let's look at this. We have, going across, we have 1/10 times 1/10, right? What is the space? As you can see, I'm drawing them in, right? What is that space that's being taken up? Yeah, You got it. The little unit, right? 1/10 times 1/10 is going to be 1/100th. And we can do that across this row. And then we're going to do that 1 time, 2 times, 3 times, 4 times. And so we see, right, we have a 3 by 4 array, right? 4/10 times 3/10 is 12/100ths. Goodness, what is going on with this pen? Sorry. Yeah, so by using the blocks, it kind of helps start to develop, right? The blocks are so important and special because of this. They show the magnitude of these numbers. So we can start to see why a 10th times a 10th makes us something smaller, right? We want 1/10 of this whole rod. We want one of these 10 pieces. So we just want one little guy. And when we do that, right, 4/10 of 3/10, we can see why we get these 12 little 100 pieces, right? 12 100ths. And then now we can just go around and add them all up. I'll erase that, right? Here's 3/10. Here's 4/10. Here's another 4/10. Here are 2 wholes, or start counting, right? If you don't like that, I'm going to erase all of these numbers and we're going to start putting them together. What do we say? We had 12 of these. So here's 1, and I can group them. Boom. And I have 1, 2, 3, 4, 5, 6, 7, 8, right? 8. And so we know we need 8 and 2 more. Boom. And now, so we know that multiplication, 2 and 3/10 times 1 and 4/10 is now 1 whole, 2 wholes, 3 wholes, 3, and 2/10 and 2/100ths. That was pretty cool. So pause it, try it again, or make up your own example. Can you make sense of that? And do this in the calculator. Is that true? Right? So I want you to help to see how the base 10 blocks can help us see this relationship between place values and numbers and compare it to the standard algorithm, right? Stack them up. We would do 4 times 3 is 12. I know you'd say carry the 1, but that's not true, right? Regroup the 1. 4 times 2 is 8, 9. 1 times 3. Oh, but put the 0 there, right? Because now, again, this is that standard algorithm where it doesn't they're just steps that we've repeated and we don't know why we do them. But we move now to the tens, or if this were a whole number, sorry, but to the next place value. So we're no longer in this place value over here. So we're moving over here. So 1 times 3 was 3, right? We saw that 1 times those 3/10 right over here. We saw that multiplication in this step. 1 times 2. 1 times 2. Our 2 wholes there was 2. Add these together. 2, 2, right? And now so now we did all this. We don't know where to put the decimal point. I know we've been told, oh, just count how many, and it goes there. But why does that work? So that's what I want you to start really thinking hard about. Why does that work? I'm going to erase this mess that I made.